Okay, Algebra 2. We're moving on to Unit 12, Day 1 notes. Day 1 is all about trig, alright? It's all review from geometry, so you guys got this down already, I'm sure. A few things, alright? I'm not going to copy it straight from the notes. You can look at those and want. Some things you should remember. Something like SOHCAHTOA. If you haven't heard of it, you should have. Alright, SOHCAHTOA is all your trig ratios all in one acronym, essentially. All right, S is sine. Sine of any angle, whatever you want to call it, is opposite over hypotenuse. Cosine of any angle is adjacent over hypotenuse. And tangent of any angle is opposite over adjacent. All right, little review. Instead of A, sometimes you'll see the symbol theta. All right, don't get hung up on all those letters though, same idea. Some other things that you're going to see in the notes where it says rationalize the denominator. How do you rationalize the denominator? Basically means get rid of the radical in your denominator. So quick example, all right, not in your notes, but easy one. Like if you had 4 over radical of 5, let's say. Can't have a radical in the denominator, so how do you get rid of it? You multiply the top and bottom by what you can't have. In this case, you can't have radical 5 there, so multiply the top and bottom of the fraction by radical 5. And simplify, just multiply straight across. 4 radical 5 on top. Radical 5 times radical 5 is radical 25, which is just 5. Alright, so you just rationalize the denominator. Started with this, now it's this. Same thing, written differently. Alright, check out the notes, there's some more of those on there. All this SOHCAHTOA stuff, right triangle trig, can only be used for right triangles. Alright, there's some examples in here. I'll do number 1A from the notes. They say find the sine of theta. The triangle looks like this. Alright, again, only works for right triangles. They give you the hypotenuse is radical 5. This leg is 1. Theta is up top right here. So how do you find the sine of theta? Well, sine is opposite over hypotenuse, so from this angle, opposite is 1. Hypotenuse is radical 5. So the sine of theta is 1 over radical 5. Alright, cannot leave it with a radical in the denominator though. So how you have to get rid of that? Multiply top and bottom by radical 5. Alright, multiply across the top, radical 5. Radical 5 times radical 5 is going to end up being just 5. Alright, they will want you to leave it in radical form, so no decimals. Stay away from the calculators, all that good stuff. Number 2, if you're looking at the notes. If not, just follow along, that's fine. You're going to see lots of these. Cosine of theta is radical 6 over 5. It wants you to find the exact value of sine of theta. Alright, whenever it says exact, that means no decimals, no calculators essentially. Remember, anytime you have cosine, sine, or theta, that's all right triangles. So just make your own picture, make a triangle. Put a theta wherever you want to, I don't know, maybe it's down here this time. So here's your theta. Cosine of this angle is radical 6 over 5. Cosine is adjacent over hypotenuse. So adjacent to this angle would be radical 6. Hypotenuse would be 5. Alright, they're saying use that to find the exact value of sine of theta. Well, theta is still here. Sine is opposite over hypotenuse. So you need to find that missing side length. Alright, nothing you haven't done before in geometry class. How do you find this? You can do it a bunch of different ways. You can do Pythagorean theorem because it's a right triangle. So a squared plus b squared equals c squared. Plug in what you know, right? I'm trying to find x. Simplify real quick. X squared, radical 6 squared is 6, equals 25. X squared equals, is that 19? So x must equal square root of 19. All right, that's not the final answer to this question though. You just found this missing side length. What is the sine of theta? So make sure you finish off the question. Sine of theta is opposite, which is radical 19 over the hypotenuse 5. There's your final answer. All right, there's a few of those in the notes. Number 3 is the same idea. Number 4 in the notes, more review from geometry. They give you some side lengths essentially, so check out number 4, I guess. They tell you the sine of theta for A is 3/10. Again, you make a picture if you want. Anytime using sine, any of those, it's coming from a right triangle. Put your theta wherever. Sine of some angle, opposite over hypotenuse. There's my 3, there's my 10. All right, it's saying, what is this angle theta? All right, let me remember, maybe not. Pretty much just go back to your geometry days. Theta is the sine inverse function. All right, inverse of 3/10. All calculator, punch that in, whatever you get. All right, biggest thing is make sure you're in the right mode. All right, you have to be in degree mode for this one. You're gonna see throughout this packet, we're gonna switch back and forth between our modes. For all day 1, you wanna be in degree mode for your calculator, all right? It's pretty much day 1, all review. There's a few word problems in the notes. Check those out, draw a picture if you need to.